9.2 is on inverse functions, finding the inverse, which means interchanging, if you're given a list of points like number 1, finding the inverse just simply means interchanging the x coordinates with the y coordinates, which means this first point would turn into 5, 0. The second one would turn into negative 6, 6. The next one would turn into 9, 8. And then the last one would turn into negative 5, 5. So again, simply it's just the inverse means to just kind of invert the x and y coordinates, interchange them. So your answer would just be this list of points right here. So on number 2 says find an equation of the inverse relation. So again, finding the inverse relation just means interchanging the x and the y, which means if I interchange x and the y, I would have y to the third x equals negative 2. So y to the third x equals negative 2, which would be this a. Now, just like we had the vertical line test to tell whether or not a relation was a function or not, we've also got the horizontal line test, and it determines whether the function is a one-to-one relation, which means the horizontal line, if you draw it anywhere on the graph, look, each horizontal line is only touching the picture of this graph one time. So it does pass the horizontal line test, which means yes, the function is one-to-one since it passes the horizontal line test. On number 4, you'll notice if you draw the horizontal line right there, it touches that relation, it touches this graph more than once. So if it touches it more than once, it does not pass the horizontal line test, which means it is not a function. Okay, for the same reason, number 5 is not a one-to-one function, excuse me, not a one-to-one function. Same reason, number 5 is also not one-to-one because it touches the graph more than once when you draw a horizontal line on it. So no, it is not a one-to-one function. And then the last one like this is number 6, using the horizontal line test again. So if I draw, it doesn't matter where I draw a horizontal line, it's only going to touch that graph one time. So yes, this does pass the horizontal line test, which means it is a function. Now, starting with number 7, it says for the following function, first of all, determine whether it's one-to-one, which means you can just plug that into your y equals. Turn on. Go to y equals, clear it out. Whoa. So my function is, because f of x means the same thing as y. So this actually is the same thing as saying y equals x minus 4. So I can go to my y equals, put in x minus 4, and then graph it. Well, it's just a straight line. It's a linear function. So yes, it is definitely one-to-one. So on these problems, if it is one-to-one, then it's going to ask me to find its inverse function. So when you're finding the inverse function, here are the steps. The steps are, first of all, replace the f of x with y. The second step is to, again, interchange. That's what makes it find the inverse. Interchange the x and y, and then the last step is to solve it for the new y now. So on this one, so we did determine by the graph that it passed the horizontal line test, so it is one-to-one. So now we need to find its inverse. So I've already switched out the f of x and made it a y. So now I have y equals x minus 4. So now I'll interchange the x and y. So I'll have x equals y minus 4. Now I'm going to solve it for my new y, which just simply means get the y by itself by adding the 4 to the other side. So now all I have left over here is the y equals, on the left side I have x plus 4. So there is your inverse. So the f to the negative 1, which means inverse of x, simply, when I solved it, it gave me that x plus 4. All right, number 8. Again, this is just another linear function, so it is definitely a one-to-one function, so we are going to need to find its inverse. So let's see, we have f of x equals 9x minus 6. So the first step, again, remember the steps to solving or finding the inverse is replace the f of x with y. So I'm going to replace the f of x. I'm just going to turn that into y equals 9x minus 6. Now I'm going to interchange the x and the y. So now I have x equals 9y minus 6. Solve it for my new y. So I'll add the 6 to both sides to get rid of the minus 6. So now I have 9y equals x plus 6. Solving for y, so I need to divide by 9. So now I'm left with y equals x plus 6 over 9. So there is your inverse. All right, so that was number 8. Number 9. Let's see, number 9, the function is f of x equals 6 over x plus 4. Okay, again, if you wanted to, you can go to your y equals, but there's a spoiler alert. These are all one-to-one functions, so you are going to have to find the inverse of all of them. So if I put this in, I'll have 6 over x plus 4. So when you graph it, you'll see it does pass the horizontal line test. The horizontal line will not ever touch that graph more than once. So it is one-to-one, which means I am using the steps to find the inverse. So I'm going to change my f of x to a y. So y equals 6 over x plus 4. Then interchange the x and y. So x equals 6 over y plus 4. So now we do have a situation. The y that we're solving for is in the denominator. So the first thing we need to do is multiply both sides by this denominator, because that's what's going to bring the y up into the numerator. So if I do y plus 4 here, I have to do y plus 4 over here. It cancels that right side. So all I have left now on the right side is that x. Not an x, a 6. Here I'm going to distribute this x. So here, x times y gives me x, y. Distribute here, 4 times x gives me 4x. So now let's see if I'm going to solve this for this y. The next thing I need to do is get rid of the 4x. So I'll subtract 4x from both sides. So now I have xy equals 6 minus 4x. And again, if I'm getting this y by itself, I need to just divide by this x. So I'll divide both sides by x. So now I have y equals 6 over x minus, these x's cancel, so I just have minus 4. So 6 over x minus 4 would be the inverse. All right, number 10 says, determine whether the function is one-to-one. If it is, find a formula for its inverse. So here's my number 10. F of x equals x cubed minus 6. So again, I can use the horizontal line test to see if it's one-to-one. So I have x cubed, so x to the 3rd power minus 6. So here's my graph of this function. Again, it does pass the horizontal line test, which means the first thing is, yes, it is 1-to-1, which means now I need to find the inverse by, first of all, using the steps. So change the f of x to a y. So y equals x cubed minus 6. Interchange the x and y. So now x equals y cubed minus 6. Solving for y, so first of all, add the 6. So now I have x plus 6 equals y to the third power. Okay, so if I'm going to get this from being to the third power just to y, to cancel out the third power, I will actually cube root. These two things are going to knock each other out. A cube root knocks out being cubed, just like plus 6 knocked out that minus 6. So these two things are going to knock each other out. Now, if I took the cube root of this right side, I must also do that to the left side. So, like we said, that cube root just knocks out the cube, so I'm just left with the y. And then on the left side, I just have the cube root of x plus 6. So that would be your inverse function. All right, number 11, the function is 2x squared plus 3, where x is greater than 0. So let's look at what that means. Let's go to my y equals. Punch in my function, 2x squared plus 3, and then graph it. Now, here's why the part of the graph that we are looking at is 1-to-1. The whole graph is not. As you'll notice, it does not pass the horizontal line test. But look what it says in here. It gives this little disclaimer, where x is greater than 0. Well, here's where x is 0 at the origin. And then all of these numbers are greater than 0. So it's saying, do not take into account where x is less than 0. So this side, so it's saying do not take into account this part of the graph, which means this part of the graph where x is greater than 0 is 1-to-1 because it does pass the horizontal line test. So yes, that part of the graph is 1-to-1. So now let's find its inverse. Okay, so if the function was 2x squared plus 3. The first thing I need to do is change f of x to y. So y equals 2x squared plus 3. Interchange x and y. So x equals 2y squared plus 3. And then solve it for your new y. So subtract the 3 from both sides. So now I have 2y squared over here equals x minus 3. Now I'll divide by 2 to cancel out that 2. I still have y squared on the right. On the left, I have this fraction, x minus 3 over 2. Now, remember on the last problem when we canceled out the third power with the third root, those two things cancel each other out. I'm going to do the same thing here. I'm going to cancel out the squared with a square root. So it knocks out the squared, so I'm just left with y. And then on the left, I just have this big crazy radical with a fraction underneath. So I have the square root of x minus 3 over 2. So when you're typing in that answer, it gives part of there for you. So it's got the 2 in this denominator. It even gives you the square root. So you just need to put the x minus 3 in the numerator there. All right, last one. F of x equals the square root of x minus 8. All right, so go to your y equals. Let's look at what this looks like on the graph. So second square root, x minus 8, graph it. All right, so it's way up. Oops, I can't see that. It is way over here. It's a square root function, which just starts here and then just goes continuously to the right. It is a one-to-one function, so I do need to find its inverse. So let's change the f of x to y. So y equals the square root of x minus 8. Interchange the x and y. So x equals the square root of y minus 8. Now, the next thing I need to do is to square both sides. That's what's going to get rid of this radical, because I'm trying to get that y by itself. Okay, once I square both sides, on the left I'll have x squared equals, this knocks out the square root, so I just have y minus 8. So now to get that y by itself, I just need to add the 8 to both sides. So now I have y equals the x squared plus 8, and since this one is actually multiple choice, whoops, there's your a, which gives you the x squared plus 8.